isn't just any hamburger. This is a hamburger with an explosive capacity. And we all know that there's chemical potential energy in food, but this one is an exploding hamburger. And if it's just sitting there, I know that it has a velocity of 0 meters per second. And if it has a velocity of 0 meters per second, then its total momentum is equal to, well, mass times velocity, but 0 kilogram meters per second. That just stands to reason. If momentum is equal to mass times velocity, let's make a little note to ourselves over here. Mass times velocity. So if it's just sitting there, its momentum is going to be equal to 0. And what's more, since kinetic energy is equal to 1/2 mv squared, what's this hamburger's kinetic energy right now? 0, yeah. We can say EK is equal to 0 joules. But then the unthinkable happens. Boom! Hamburger explosion. Buns off, honey. All right? So everything goes everywhere. Meat goes one direction, top bun, bottom bun. And we got to have some notation for this. And so we say maybe we have a component, a portion A, a portion B, maybe a portion C. And of course that means that there's going to be a momentum A and a momentum B and a momentum C. And we said once before that one of the ways to indicate like a before and after is to do initial and final, like an I and an F in the subscript. Another way to deal with before and after is a 1 and a 2. Before, like, you know, 1 is for before and 1 is for after. Now the thing is, here I've got 3 different objects, and it's hard to keep track of 3 different objects. And if I have too many things in the subscripts become ungainly. They just become a little bit difficult to deal with. So another way to deal with the before and after is to use prime notation. And so that's what I want to introduce a little bit more today. Spend a little more time using prime notation. But that would mean that I have P total. Notice there's no prime, so it must be before the incident, right? But I've got PB primed, PC primed, and PA primed. Now, if I was going to talk about PA before, PB before, and PC before, I would just drop the prime. But also, since it was all just kind of together, all the momentums would have been 0 because as a whole hamburger it was 0, right? And so what I could say is P total primed is equal to PA primed plus PB primed plus PC primed. Now if the total momentum was 0 before, I mean the momentum diagram for that one is easy. I mean it just consists of being a dot. There's no vectors at all, right? But if I want to talk about the total momentum after being 0, I would add up those vectors tip to tail, and my PC primed might look like this. You know, going off at an angle. See, that's my PC prime. And my PA primed might look like this. And my PB primed would look like this. Hard to write small enough. Oh, you know what? I feel like you guys can keep yours, but I'm going to make mine bigger. PC prime going off like this. PA prime going up like this. I'm scaling it up now. And PB prime going down like this. And I know that if I'm doing a little bit of hand waving with my scaling here, you can see that I've kind of got the idea. I'm going sort of southwest-ish, I'm going sort of northwest-ish, and going sort of southeast-ish with these vectors. I haven't done it like perfectly to scale, but you get the idea, right? That we can add these guys up to tip to tail. And I really am adding these vectors up tip to tail, just like we've always added up vectors. But if I need to have a 0 sum before and after, can you see that this vector system adds up to 0? It comes back on itself, right? And if I needed to do that by components, which you guys probably will have to do in a lab eventually, I'm just telling you. We won't blow up hamburgers, but we'll do something, okay? It means that I'd have to break these guys up. I'd have to have like a PA primed Y, and I'd have to have a PA primed X, and I could label them up PA primed Y, and see I already have a lot going on in the subscripts there, so I wasn't really keen on putting a before and after as well. I'd have PA PAX primed. I got PBX primed. I have PBY primed. And then same for the C. PCY primed and PCX primed. And it might be easier to show that the total momentum is 0 after by saying, look, all the x's add up to 0. All the y's add up to 0. And you can see that as much as this PCX goes over to the right, PCX prime goes over to the right, PAX prime and PBX prime goes the same amount over to the left, right? So dealing with it in x and y is going to be the responsible way to deal with this. It'll be much easier than trying to deal with it as just like a two-dimensional shape, right? And people say, well, could you extend this to 3 dimensions? Well, yeah, of course you could. It's just that we'd have to have like a z component to these axes. And of course, like when hamburgers really do explode, when, not if, there's going to be z components too, right? And of course, I'm keeping this as hamburgers because there are obviously other more triggering things that could be exploding, but I'm just going to keep it as food. But if I say PTX primed adds up to 0 and PTY primed adds up to 0, I can effectively say that the x components are conserved before and after, and the y components are conserved before and after. Because really, even though it doesn't look like much, that little dot there does contain within it the truth that p total x equals 0 and p total y equals 0. It's just a really boring vector diagram because it's just a dot, right? And so really, the x and y momentums have been conserved before and after independently. We don't have to think about it as a whole two-dimensional thing. We can think of it as an x conservation and a y conservation. Okay? I got this train though, and the train, this is back to 1 dimensions by the way. The train collision is a nice classic question. And I want to take a second to talk about that.